Hello friends, this is Stimulating Science. Now we are going to study about the process glycolysis. Glycolysis is also called EMP pathway. EMP pathway because it was actually given by Emden, Meyerhoff and Parnas. Therefore EMP pathway. So glycolysis is the common path for both aerobic and anaerobic respiration. That's important. Again, I'll repeat, it's the common path for both aerobic and anaerobic respiration. Okay, so first step involves glucose getting converted to glucose 6-phosphate. Now, where does this glucose come for any respiration? For suppose if it's plant, we get it from sucrose, which is nothing but the end product of photosynthesis, right? Product of photosynthesis is sucrose. So sucrose is converted to glucose plus fructose with the help of the enzyme invertase, and this glucose gets involved in the glycolysis or EMP pathway. So glucose gets converted to glucose 6-phosphate with the help of the enzyme hexokinase, and therefore there is a loss of energy. Okay, ATP is converted to ADP. Now this glucose 6-phosphate is also a 6-carbon molecule, and it can interchange with fructose 6-phosphate by the action of the enzyme phosphohexoisomerase. Again, isomerase. Okay, here also you will get isomerase, and later here also you will get isomerase. Now this fructose 6-phosphate gets converted to fructose 1,6-bisphosphate. Bisphosphate, right? So by the action of the enzyme phosphofructokinase. Again, there's a loss of energy. ATP is converted to ADP. So this fructose 1,6-bisphosphate with the help of the enzyme aldolase gets converted to two molecules. This is also 6-carbon, right? This 6-carbon gets converted to glyceraldehyde 3-phosphate and DHAP, nothing but dihydroxyacetone phosphate. This is 3-carbon, this is also 3-carbon molecule. And this G3P, nothing but glyceraldehyde 3-phosphate, can interconvert with DHAP with the help of the enzyme phosphotrioisomerase. Isomerase, here also isomerase. This is phosphohexoisomerase, but this is phosphotrioisomerase. Okay, important. So coming to glyceraldehyde 3-phosphate, it gets converted to 1,3-bis phosphoglyceric acid, and here the enzyme involved is glyceraldehyde 3-phosphate dehydrogenase. That means hydrogen is removed, right? If hydrogen is removed, there must be an acceptor for hydrogen. So NAD accepts the hydrogen and gets converted to NADH2. And also there is an addition of H3PO4 in this reaction. This 1,3-bisphosphoglyceric acid now turns into 3-phosphoglyceric acid by the action of the enzyme phosphoglycerate kinase. And this phosphoglycerate kinase is Mg2 plus dependent. Okay, Mg2 plus is the cofactor for it. And by this process, an ATP is generated from ADP. Okay, now we are gaining the ATP, and here we are losing the ATP, right? Now this 3-phosphoglyceric acid gets converted to 2-phosphoglyceric acid by the help of the enzyme phosphoglyceromutase, right? Phosphoglyceromutase. And this 2-phosphoglyceric acid gets converted to phosphoenol pyruvate, and the enzyme involved is enolase. Enolase is again Mg2 plus dependent. Okay, and by this process there is a loss of water. So H3PO4 is added when glyceraldehyde 3-phosphate is converted to 1,3-bisphosphoglyceric acid, whereas H2O is removed when 2-phosphoglyceric acid is converted to phosphoenol pyruvate. Now coming to the last and final step, that is phosphoenol pyruvate gets converted to pyruvic acid, right? Phosphoenol pyruvate gets converted to pyruvic acid with the help of the enzyme pyruvate kinase. Again, this is Mg2 plus dependent, and not only Mg2 plus but it's also K plus dependent. So again here we are gaining an ATP, right? Now coming to the energetics. Okay, this is important. So the first step we are losing an ATP, and in the third step we are again losing an ATP, right? So lost equals 2 ATP. And coming to the most tricky one, how many we are gaining? Friends, let's count them. NAD is converted to NADH2, and we all know 1 NADH2 equals 3 ATP, and how we are going to study later, but just know this, okay? NADH2 equals 3 ATP, and here we are gaining 1 ATP, so 3 plus 1 4 plus, and in the last step we are also gaining 1 ATP. 4 plus 1 5, right? So can I write the gain as 5 ATP? Sorry, not 5 but 5 ATP. It's actually a wrong way of calculating, because this DHAP must also be converted to glyceraldehyde 3-phosphate when we are considering the energetics. Okay, so let's take only this part. Glyceraldehyde 3-phosphate gets converted to pyruvic acid in the last step, right? So by this process it gains 5 ATP, right? Just now we have counted. Now due to this phosphotriose isomerase, this DHAP may also be converted to G3P or glyceraldehyde 3-phosphate, right? So when this is also converted, again there's a repetition of this process, right? So again we are going to end up with 5 ATP. So 5 plus 5 is going to be 10 ATP. So gain is not 5 ATP but it is 10 ATP. Let me repeat it again. Because DHAP and G3P can interconvert with each other, we must also consider DHAP being converted to G3P during this cycle. If we just take G3P undergoing this process, we'll get NADH2 is equal to 3 ATP, 3 plus 1 4, 4 plus 1 5. But even DHAP will involve in this reaction, right? So when DHAP involves, we are again going to end up with 5 ATP. So 5 plus 5 is going to be 10 ATP. So gain is 10 ATP. So net ATP gain equals 8 ATP. Okay, so it's important that the net ATP gain in one cycle of glycolysis is going to be 8 ATP, right? Now let's also state that the enzymes dependent on Mg2 plus. Mg2 plus dependent enzymes. As we already seen, let me mark it as phosphoglycerate kinase. First one is phosphoglycerate kinase, which is involved in the conversion of 1,3-bisphosphoglyceric acid to 3-phosphoglyceric acid. And the second one is enolase, right? Second one is enolase. And the third one is pyruvate kinase. Pyruvate kinase, which is involved in the process of converting phosphoenol pyruvate to pyruvic acid. Okay. And one more thing is that hexokinase is also dependent on Mg2 plus, and phosphofructokinase is also Mg2 plus dependent. Simply you can remember kinase, if it ends other than enolase, it will be dependent on Mg2 plus, right, other than enolase. So we can also add hexokinase and phosphofructokinase. This is phosphoglycerate kinase. This is phosphofructokinase. Okay. And one more thing, friends, this phosphofructokinase is the pacemaker of EMP or glycolysis. Okay, this question is important. Phosphofructokinase is the pacemaker of the EMP pathway. Now, coming to the conclusion, so we have seen ATP is utilized over these areas, so we can also say it is an energy consuming phase, right? Whereas these processes are actually producing energy, so they can be called as energy producing phase. So that's all for the glycolysis. Thank you friends for watching.